In this video, I'm going to be showing you how to create your own Super Mario Galaxy-esque gravity system. The project and code files for this will be down in the description if you would like to have a copy of this project for yourself. So to get started, let's take a look at my playable character here, Mario. So it's just a player object. I have it tagged with the player tag. I also have a player collider tag, which goes onto his capsule collider here. On my player game object, I have their transform, rigid body set to continuous detection for collision. I froze the rotation values in the constraints section here. I turned off use gravity because we're going to use our own. I have our player controller, and I'll go into more depth on what this is. I have a box collider that is a trigger, and that is actually this bar right here, and that is just detecting if the player is actually touching the surface of a planet. You could get a similar result with a raycast, but I was lazy and just felt like using a box collider. Then the last thing here is an animator, and that's just to animate some movement while he's walking around so he doesn't just T-pose the whole time. So I'm going to collapse the box collider and the animator and the rigid body. Make sure the rigid body stuff is all set how I have it here, or else it might not work. The next thing is I have a visual child object for the player, and this is just a bucket for the collider and the model. And that is pretty much all there is to the player character. Now, if we want to look at our planets, you'll see they all look kind of different, but they're mostly all the same, at least how they work. So for this sphere planet, I have the sphere mesh filter, the mesh renderer, and a mesh collider. Since this is a sphere, I could just use the sphere collider, but I wanted it to be the mesh one just so if I change it like this or like stretch or squash it, I could just do it like so and then it would still work and the collisions are just fine. So that's why I have it like that. I'm just going to put this back. Underneath the mesh collider, I do have it set to convex here. But underneath that, we have our planet controller script, and we can get into that a little bit later too. Underneath the sphere, so just like the planet object, I have a game object with a mesh collider that is convex and is trigger with the sphere mesh. Again, this could be like just a sphere collider if I wanted to, but this is also scaled up so you can see like this wireframe around the planet, and that's going to be the trigger for if the player enters that, then it's going to change which planet the player is assigned to for gravity. Other things I have are just decorations, so just warp pipes. So no big deal there. This is just a copy paste of the other sphere planet. This cube planet is the same thing, except it uses a box collider and the cube mesh. Same thing for the bounds for the gravity. Capsule is the same thing, same setup. All of them have a planet controller, and we'll see what that does in a little bit. And then this one is my weird shape model. I just kind of put something in Blender and squished and stretched it a lot. So for this one, to get the best results, if you don't want the player like phasing through the planet with like willy-nilly collision detection, I had to add a rigid body to this object itself and choose extrapolate for interpolate, is kinematic is checked, use gravity is unchecked. Collision detection is on continuous dynamic, and I've had the best results for that. And then underneath the constraints here, I set all of the constraints to freeze the position and rotation. And then underneath it is just a mesh collider convex with is trigger. Again, I have a warp pipe for decoration on this one too. Now that we know how everything's set up in our scene view, I'm going to go back to our player character, and I would like to show you the player controller script I have here. So if I go up to the top, this is going to use the Unity Engine input system. So I have mine just set up for controller input. This is what it looks like. It reads the right analog stick. The left analog stick already goes through the horizontal and vertical axis, so I can use that for movement. But for camera control, I need the right analog stick and then the gamepad east button. So if you have PlayStation, that's going to be circle. That is going to be for jump. So it might be good to look up that input system if you're not familiar. Otherwise, I believe you could set this up with just like keyboard mouse controls if you would like. All right, so let's get started with our variables. I have a couple public and private floats here to start off with. Raycast length is going to be the length of the raycast from the player to the planet to get what face it intersects with the planet model, and that'll make more sense later. So that's just the length of the ray that we're casting. Rotation speed, that's going to be the speed at which the player rotates to conform to the direction of gravity on a planet. Temp rotation speed, I have this here as a private float to hold the default rotation speed value, because at certain points in the code I do change the rotation speed based on what's happening. Public float speed is just movement speed, so how fast Mario walks. The public float for gravity is how strong gravity is. And then I have a private float for temp gravity, and that is going to hold the original value for gravity because I do change the value of gravity depending on what's happening, just like I do for the rotation speed. Jump force, that's going to be the amount of force that you use when the player jumps. Reference to our rigid body, so that's a private variable. I have a public transform for the current planet, so whatever planet you're currently assigned to is going to be stored here. Public transform for the player visual, so that is going to be the visual game object in our scene. So for our player, we have this game object that holds the model and the collider. That is what that's referencing. Then if we move down here, we're going to have an array for our raycast hits. So any objects that are raycast hits, it will be listed here as a hit. Vector 3 for planet dir, so that stands for planet direction, or direction to a planet, direction to the current planet. Vector 3 normal vector, that is going to be the vector from the planet that points in the upward direction, so opposite of gravity. Input as a vector 3, that's just going to be, that's like input from my left analog stick. So if you were using like the arrow keys, it'd be like that input as well. Public bool, this could probably be private, but I have it public just so I can see it, is touching planet surface. That is going to be true if the player is standing on the planet, and this box collider here, that is a trigger. If that is intersecting with the surface of the planet, then it will be true that the player is touching the planet surface. A transform for the main camera, a transform for the camera arm, and that is just my third-person camera rig that I set up. So I have my own camera target. This camera target follows the player with a certain damping speed. But this camera arm is just an arm to like rotate the view of the camera. So if I do this, you can kind of see what I mean for the camera arm. If I rotate the Y axis, it does that. That's not really important to this video, but that's what it does. I also have a ARM controller script for this for like sensitivity and how far to clamp the X rotation. And yeah, that's what's going on with the camera. It's referenced in this script because we're going to make the movement based on the direction the camera's facing, as well as what input the player is giving. So like if the player is giving a forward input, but the camera's on the side, you don't want them to run to the side or whatever. You want them to run forward based on like camera direction. So that's why that's all there. Player controls, those are going to be my input controls. Anim, that's my animator. A Boolean for jumping, so can jump is true by default, and then there's sometimes where you can't jump. Bool to slow down, that is false by default, and it becomes true when the player enters in like another gravitational field. So like if they intersect with another planet's gravitational field and it switches, then we turn slow down on. Then the player kind of slows down, it rotates to face the new planet, and then it can kind of fall to where it needs to go. So that is what all of these variables are and what we expect them to do. Now let's look at our awake statement. We get our rigid body component, we get our main camera transform, get our animator, set our temporary gravity to gravity, set our temporary rotation speed to rotation speed, and I am initializing my player controls, and then I'm saying for the movement controls, if the gamepad east button is performed, then call the jump function. On enable, I'm just enabling my player controls. On disable, I'm disabling them. So since I'm calling the jump function here, let's take a look at that real quick. Jump is going to have input action callback context. That's just needs to be there for this to work. If the player cannot jump, then this function just returns. When they do jump, the velocity gets set to 0, and then a force is added in the direction of the normal vector times the jump force as an impulse. Gravity is temporarily cut in half, and then I call an invoke for 1 second from this point to restore gravity. Can jump is set to false, and rotation speed for the player is cut in half as well. And the restore gravity function that I'm invoking here after 1 second just restores gravity to the original value, sets can jump to true and slow down to false. Even though I didn't do anything with slow down here, I do somewhere else. So let's go back under fixed update. First function I call is movement. So for movement, I have my input vector 3, and I'm getting the horizontal axis in the X field, the vertical axis in the Z field, getting a vector 3 for camera rotation, and I'm making a new vector 3, 0 on the X, 0 on the Z, but for the Y, I need the local Y rotation for the main camera transform, as well as the local Y rotation for the camera arm transform, and then that's going to be the value for Y in this vector 3. Vector 3 called dir for direction. This is going to be a quaternion from this camera rotation, and it's going to be multiplied by the input. This is what's causing us to move with the camera direction added in, rather than moving independent of the camera. Vector 3 movement direction. This is going to be the direction of the movement based on what way the player is oriented at the current time. So in the forward direction, we want the dir vector. We want its z value. So again, that's going to be this input get axis raw vertical value. Then we'll want to also add in transform.right times the direction vector times its z value. And this will get you the xz directions for like the local movement directions on the xz plane for the player. So like horizontal movement. As far as vertical movement though, we want to still preserve the gravity. So if we were to just like set velocity equals this times speed, which we do right here, if we were to just do that, then gravity would get canceled out, and whenever you have an input for movement, the player would stop falling and they would just move like horizontally along like the surface of the planet or whatever. So to make sure that doesn't happen, I made a vector 3 called current normal velocity. It uses the vector 3.project function. It says it projects a vector onto another vector. So I want my velocity vector projected onto my normal vector. So I'm using rb.velocity, normal vector.normalized. The normal vector should already be normalized, but I just do this just in case. And then for velocity, I just add the current normal velocity to the movement direction times the movement speed. And down here, if the movement direction, so that's going to be this value, if it is not equal to vector 3.0, then I'm setting my animation boolean for is moving to true, and I am rotating the local rotation of the player visual. So just like the model of the player, I'm rotating that using quaternion.look rotation to the dir value. So that's just this value. It's our input multiplied by our camera rotation quaternion. So essentially this is making the player look in whatever direction they're moving, and this is setting the animation so it looks like they're moving. Otherwise, the moving boolean for the animator gets set to false, and then the animation will just play the idle state. And then lastly, if the slowdown variable is in effect, then the velocity just gets multiplied by 0.5, so it gets cut in half each time this is ran. So that just slows down however fast Mario's moving at the moment. And if we go back to our fixed update, the next step is apply gravity, which is right here. So if the current planet is null, so meaning we don't have one, then we just return this. Since if we don't have a planet, we're not going to be able to apply gravity. Hits is our array for the raycast, for like everything the raycast hits or intersects with. So this initial hits array is going to use physics.raycastAll, and it's going to fire array from the transform position, so our player position, in the down direction, so negative transform.up. If there was a transform.down, this would be the same thing as that. I don't think there is one, though. Let me see. Yeah, no, there's not. At least not in this version. So it's going to fire a raycast from our player position downward with a certain length, so our raycast length variable here. I have some walls, I like to call them. If hits.length is 0, then I'm going to check the forward direction instead. If that is 0, then I'm going to check the backward direction. If that's 0, I'm going to check the right. And if that's 0, I'm going to check the left direction. And if that's 0, last resort, planet direction equals the current planet position minus the current player position. So just a straight line from the player to the planet. And it's going to do hits equals raycast from the player position to the planet direction, raycast length of whatever we specify here. Then I call a function called getPlanetNormal, and that function is just going to set the normal vector for the planet. So after this is called, then the rigid body gets a force added to it in the direction of the normal vector multiplied by our gravitational value as an acceleration force. And then I clear out hits by setting it equal to an empty array. So if we go back to this getPlanetNormal function here, we can see if current planet is null, we return, because if the current planet is not set, then we cannot get a normal vector from it. The normal vector is going to be equal to the position of the player minus the current planet position normalized. So this is going to be like the dumb, stupid way of setting it. This works fine for spheres. It's also a good fallback. But if you have any weird shapes, this isn't going to be effective enough. So since we want to walk on weird shapes, we'll have this for loop, and it's going to go through all of the hits, all of like the game objects that were hit by the raycast, and we'll compare if the transform of the object that it hit is the same as the current planet that we have assigned. If it is, then our normal vector is going to be that game object that it hit dot normal dot normalized, and then we're going to break out of our for loop and return. So what this does is it gets the normal from whatever face it intersected with for the colliders. So a normal vector is just going to be the direction that like a face is facing. So if you just had like a square and drew an arrow pointed directly up from it, then that would be the normal vector. Our player is going to be aligned to the normal vector that we have set here, and that is what's going to allow us to walk on weirdly shaped objects in our scene. So let's go back. We just got our planet normal, we applied our gravity, and now we need to apply planet rotation. So if I go to that, we can see here that I'm setting a quaternion for the target rotation, and that is using quaternion.from_to_rotation. And this is just like going from one rotation to the other. So we want our transform.up value to go to rotate to the normal vector value that we're getting from our previous functions. And then we're multiplying by our current rotation. And then right here, I'm going to set our rotation equal to a quaternion.lerp function. So it's going to linearly interpolate between our current rotation and our target rotation by a rotation speed, and I'm multiplying it by time.fixedDeltaTime. And then I have a statement here: if the player is touching the planet's surface and can jump, then the rotation speed is going to be set back to the original rotation speed value. Because normally when you jump, I think I cut the speed in half is what we said. Let's see. Yeah. So if you jump, you cut the rotation speed in half. But once you land, then it's going to be set back to the original value. If we go back up to our fixed update, that is the last function there. And then the only things left are on trigger enter here. If a collision is detected, then I check if the transform is equal to our current planet. If it is, then I am setting is touching planet surface to true. If other transform on exit is our current planet, then we are not touching the planet surface, so I set that to false. And that is pretty much it for this player controller. And if we can see here, in our scene, here are the values that I have set. So I put a raycast length of 3, rotation speed of 15, a speed of 25, gravity negative 300. Gravity in this setup can be a little finicky, so kind of have to play around and get whatever feels nice for your game. Jump force I have at 100. Current planet I have it set to sphere by default, so that is just this one. Player visual, that is just going to be this game object, this child object, and just drag it in here for the reference. Camera arm transform, that is just this camera arm transform object here. So again, I just drag that in here, and that's just for the third person camera I have. If you have a better one, feel free to use that and take that code out. The next thing that we will be able to look at is our planets. So on our planets, they each have a planet controller. So if I open that up, pretty simple script. It's just an on trigger enter, and I set player controller here by getting the player controller component from other. If it is not null, then we run this. So assuming other is the player and we are able to get the player controller, then if player controller.currentPlanet is the same as this transform, same as like the object that this planet controller is on, and then we just return, since we don't want to constantly set the planet to this planet to the current planet if it's already set. The next line, so assuming this is not the case, then we do set the current planet to this transform. And then for the player controller, we call the enter new gravity field function. And if we go back to our player controller script, we can see enter new gravity field here. Gravity is divided by 4. The velocity of the rigid body is multiplied by 0.5, so cut in half. Rotation speed is divided by 10. Slow down equals true. Can jump equals false. So when it's orienting itself, you're not going to be able to jump, which is fine, I believe. And then it invokes restore gravity function, this one right here, after half a second. All of this can be tweaked and tuned to your liking, but this is just what I found works for me. So we can go ahead and start playing here, and I will jump, and you can see when we enter in those new atmospheres, we can start walking on the next planet's surface. So yeah, we can jump around, hop onto some weird shaped planets, and it should be mostly fine. I don't know if I'd rely on this for like an entire game, but it could be just like a cool short section of a game. But yeah, if you like this video, feel free to leave a like down below. Again, the project files are going to be in the description if you want to see exactly what I have for my setup. If you want to copy any of the textures or my skybox shader, feel free. But yeah, thanks for watching. Goodbye.